Okay, let's look at this Newton's Law question from November 2017. It's only got one block, but it's on an inclined plane. So the first thing we must do before we start this question is remember that when we have an inclined plane, we're going to work with components of the weight. So there are two components of the weight, Fg parallel and Fg perpendicular. And it is your job to remember that Fg parallel is equal to Fg sine theta and Fg perpendicular is equal to Fg cos theta, where Fg is synonymous with the weight, which is the mass times the acceleration due to gravity. But we like to use this Fg code to pretend that we do physics. Okay, so it says to you, an 8 kilogram block is being pulled by a constant force F up a rough inclined plane. So rough, we know we are going to have friction, okay, at an angle of 30 degrees to the horizontal at a constant speed. If there's a constant speed, we are in equilibrium, okay, and my acceleration is going to be 0. It says force F is parallel to the inclined plane as shown in the diagram below. Okay, so this is pulling the block up the plane. State Newton's first law in words, learn your definitions. This is the one about inertia and how a body at rest or at constant motion will remain in its state of motion unless acted on by a net or resultant force. Remember it word for word properly. Now it says, draw a labeled free body diagram for block P. Remember, 4 marks, we need 4 arrows. Now remember as well with these inclined plane things, they want the free body diagram with the actual forces. But when we draw this, okay, remember that what you can do is you can draw in pencil very lightly a slope, okay, draw it in lightly. Now draw your block, your little blob for your free body on the slope. Using your ruler, you draw down immediately. The weight is the first force we're going to think about, Fg. Okay, so an acceptable label is Fg or small w for weight. Okay, remember big W's work. Now, the moment that we've got an object on a surface at right angles to the surface, we always need the normal, which is Fn, which you are going to draw in with your set square to this very thin pencil line that you drew in. So to be sure that this is at right angles. Then it says to you force F is parallel with the slope, so you can go over your faint line here and you can draw in force F, okay, the applied force. And because it is a rough slope, we know that we have friction, and the friction is going to oppose the motion. So motion is up the slope, friction is going to go down the slope, and the acceptable one for friction is little f, and if it's moving you can put little fk if you like, but I'm struggling to write small letters in here. And as you can see, I went back and I erased my very faint pencil line, so I now have a very nice force diagram for my 4 marks. 4 marks, 4 arrows, each arrow must have a label. Now it says to you calculate the magnitude of force F. So now we have this very lovely force diagram. The problem is this lovely force diagram, we cannot add these forces because Fg is not in line with any of them. Remember, we can only add forces when they're in a straight line. So we're going to draw our own diagram, and because I'm short of space, I'm going to draw on this diagram. Okay. So now you need to draw in your own diagram with the components of the forces. So here will be Fg perpendicular to the plane, and over here will be, let's make it longer, Fg parallel to the plane. Okay, and now you can see we have forces in a straight line parallel to the plane and forces in a straight line perpendicular to the plane, which is going to make this question much easier for us to solve. Okay, because we can only add forces in a straight line. Now it says to you, the kinetic frictional force between the block and the surface of the inclined plane is 20,37 newtons. So this Fk is 20,37 newtons. So it says calculate the magnitude of force F. So it's at constant speed. So the first thing we're going to do is we're going to say F net equals ma. For 1 mark, write the formula. But we know that because it's at constant speed, the ma is going to be equal to 0. But what will be the net force on this block. We can say the direction of motion is positive. Okay, so if we say the direction of motion is positive, any arrow that is going in the direction of motion, the number will be positive. Any arrow that is opposite the direction of motion, its number will be negative. So we have to add the forces together. So in the direction of motion, we have the force F, the applied force we're trying to find. And then opposing motion, we have the kinetic friction going down the hill. And opposing motion, we have FG parallel. And these are all going to equal 0. So can you see I've got 1, 2, 3 forces parallel to the slope, and I've got 1, 2, 3 forces here in my working out of the net force. So we're trying to find F. They told us that FK was minus 20,37. Well, they told us 20,37, and I'm saying it's minus because it's opposing motion. And then we have FG parallel, which I told you right at the beginning is FG sine theta. So FG is code for the weight. So this block has a mass of 8 kilograms. How do we turn mass into weight? We multiply by the acceleration due to gravity. Okay. And then sine and theta here is 30 degrees. This is going to be equal to 0. So F is going to be equal to 20,37 plus, and this 8 times 9.8 times sine 30 is 39,2. So we end up with a force F of, calculator, 59,57 newtons. Okay, so the force is 57,57 newtons up the slope. Now, it says to you, force F is now removed. So this force has been removed, and the block accelerates down the plane. The kinetic frictional force remains the same. Calculate the magnitude of the acceleration of the block. Well, when I first looked at this, I thought, oh, look, easy peasy. Here we go. And I tried to work out the answer, and then I thought my block was suddenly going at like really warp speed. And then I realized I must draw another free body diagram, because you must always draw your free body diagram. So there's my little block. Okay, I'm now missing this force F up the slope. But my block is going down the slope. Remember, the block is now going down the slope. And what does friction do? Friction is that lovely contrary force. It opposes motion. So the friction is now going up the slope. I still have my normal force. Sorry, I'm not drawing it to scale. I still have my FG perpendicular. And I still have my FG parallel going down the slope. So I have removed this big force F over here, okay? But in removing this force, the weight of the box starts pulling it down the slope. And because it's going down the slope, the moment it goes down the slope, my friction switches over to the other side. So now the block is accelerating. So again, the direction of motion is positive, okay? So what we have to do, F net equals MA. Now there is an A, we have to find the A, but let's look at the net forces. So FG parallel is in the direction of motion, minus the kinetic friction is going to be equal to 8A, because the block weighs 8. So we can actually just whip this FG parallel from over here. It's 8, 9,8 sine 30 minus, remember 20,37, they said it changes the same, stays the same, gives you 8A. So remember this value, we found this value was what, 39,2. So now it's 39,2 minus 20,37 equals 8A. So if you do algebra, running out of space here, subtract these two, divide by 8, you should end up with 2,35 meters per second down the slope. And because it only said magnitude, you don't have to write down the slope. This is your final answer, because magnitude just wants the number. So it's 2,35 meters per second down the slope.